Yes, guys. Right. Yeah. So let us see few previous year questions here. So one question actually is a simple question if you remember the concept. Otherwise, you may confuse. So let me give the question first. The question is actually it is NEET 2017 question. NEET 2017 question. The question is an arrangement of three parallel straight wires. An arrangement an arrangement yeah of three parallel straight wires parallel straight wires placed perpendicular to placed perpendicular to this symbol denotes perpendicular, guys, perpendicular to the plane of paper, plane of paper carrying same current I, carrying same current I along the same direction along the same direction as shown in figure, as shown in figure. Magnitude of force per unit length. Magnitude of force per unit length on the middle wire B, on the middle wire B is given by right options. First, note down the diagram, the figure which is given here. So here there is a wire in the middle is in which current is flowing in a direction given by dot. Dot means out of the plane. Is a wire B in which current is flowing out. Okay, and there is another wire A in which also current is flowing in same direction out of the plane of the paper. and there is another wire C in which also current is flowing in same direction, that is out of the plane of the paper, and they are placed at A and B are separated by a distance D. I can mark here, this is the distance between these, and B and C are also separated by a distance D. This distance of separation between B and C is also D. Draw this diagram properly, and it is obviously from the figure it is clear that the angle between the line joining AB and BC should be 90 degrees. They are perpendicular. Okay, done. Now what is the question? What is the force, magnitude of force per unit length on the wire B is the question. So they are you can read the question once again clearly and note down the points, given data, and you can carry on. If they are long wires, means you can consider them as infinite current carrying conductors. Okay, now for total force on B is equal to, here note down the options first, then you can go through the solution. Options, first option is mu naught I square by mu naught I square by 2 pi d, and second option is a 2 mu naught I square by pi d. Third option, root 2 square root of 2 mu naught I square by pi d, and fourth option mu naught I square by root 2 pi d. Right. Okay, so how to do it? So you can say the net force on B you want. Net force on B is equal to force on B due to A plus force on B due to C. You have to just decide whether they will be in same direction or not, also vectorially. So better you write vector sum. These are vector sum. If they are in the same direction, you can add them. Otherwise, you have to take the what do you call sum accordingly. So here, just you can visualize with the help of you take the pen which you are using to write, and just to understand the force on B, first try to understand the direction of magnetic field there. So magnetic field will be towards left. If you stretch the thumb of right hand along the direction of current of A, and if you stretch the fingers onto the conductor B, you can understand that magnetic field will be towards left. Whereas due to the conductor C, if you observe, the field should be uh, downwards, they are perpendicular. Then force on a current carrying conductor in general, as is given by I, L, B or L cross B, right? So force on B due to the magnetic field of A, force on B due to A, as field due to this is to the left, L cross B, as the current is outward, L cross B will be down. So you can write down means along negative y direction. Only magnitude you want. So this you have to visualize carefully, guys. Okay, so here F1, you can understand that force on B due to A will be downwards. By using your right hand thumb rule, you can visualize it. Similarly, force on B due to conductor C. Due to conductor C, magnetic field will be downwards, as the current in this is outward, L is outward. I can write it as L cross B will give you a force to the rightward direction. So force on B due to C will be in this direction. Just simply you can take this as F1, F2 also. Yes, this is, let us say, F1, let us say this is F2. Resultant of these two forces is nothing but your force required. Obviously it should be somewhere here in this direction. Fr resultant. So here you can write Fr is equal to, here the angle between these two forces is 90 degrees. So Fr is equal to square root of F1 square plus F2 square plus 2 F1 F2 cos theta under root. Yes, try this properly guys, visualize properly, otherwise we'll confuse. Once you understand those, you can substitute this. Here obviously one more thing is the distances are same, and L and B are same. Magnitudes of F1 should be equal to magnitude of F2. That is also we can mention here. So F1 should be equal to F2 is equal to, let us say, F. F is nothing but ILB. You can substitute this at the end, but here you can write it and you can keep aside. It is nothing but ILB. And hence this is equal to I into L into B. B is nothing but field due to either here, either A or B here. Due to infinite conductors, so the distance, the perpendicular distance is nothing but mu naught I by 2 pi d. Mu naught I by 2 pi d is B. So this is your F. You can substitute this at the end, and here the angle between F1 and F2 is 90 degrees. 90 degrees. Substitute this here, then Fr becomes, Fr is equal to square root of, as F1 equal to F2 equal to F, as F1 equal to F2 is equal to F, you can write this as F square plus 2 F into F is F square into cos theta is 90. So cos 90, what is cos 90? Cos 90 is 0. So this entire term becomes 0. So they'll get square root of F square plus F square is 2F square. So F square comes out and you will get root 2 into F will be your resultant force. Root 2 into F. So you can take this as, therefore, F magnitude, just magnitude of resultant is root 2 into F is this mu naught I into IL. You can write it as, here itself you can write mu naught I square L by 2 pi d. So this you substitute here, mu naught I square L by 2 pi d. So if this is there in the options, you can choose this directly. Here, based on the given options, you have to simplify further. So is this in there in the option? You can cross check. 2 root 2 mu naught I square L root 2 part, if you observe, in the numerator part only option C is there, but in denominator nothing is there, but here 2 is there. So if you want to simplify this further, you can write this 2 in denominator as root 2 into root 2. Then final answer becomes Fr is equal to root 2 cancel, then it becomes mu naught I square L by root 2 pi d. On further simplification, you can write this way also. So is there in the options, you can cross check mu naught I square L, but you want force per unit length, so bring this L here down. Force per unit length, so Fr by L is equal to mu naught I square by root 2 pi d. So which option gives this mu naught I square by root 2 pi d? Option D. Option 4. Fourth option. So this is how you have to do this kind of questions. So you may feel that S is very simple, I know, but while taking the directions of magnetic fields and hence the directions of forces, you have to be little careful, and you have to do this in a minute. So you need a practice, proper practice. So pause the screen and write down clearly step by step without seeing, you just write practice, so that you should be able to do within a minute, 2 times or 3 times depending on your understanding the fastness. Try to improve your fastness, speed, so that you should be ahead of others. Then obviously you will be ahead of in your result also. Next, one simple question I will give you, that is based on force between parallel current carrying wires. Force between parallel current carrying wires. A simple question. I hope it may not doesn't need even 1 minute also. You can try. Yes, the question is two long two long parallel wires are at a distance of at a distance of 1 meter. Full stop. Both of them carry both of them both of them carry 1 ampere of current. Yes. The force of attraction per unit length. The force of attraction per unit length. The force of attraction per unit length between the two wires. Per unit length between the two wires is, it is of course long back question, 1998 NEET question, but you have to just have an idea that this kind of questions are also have asked, and in different exams also asked later. You can note down the options. First option, 2 into 10 to the power minus 7 Newton per meter. Second option, 2 into 10 to the power minus 8 Newton per meter. Third option, 5 into 10 to the power minus 8 Newton per meter. Fourth option, just 10 to the power minus 7, means 1 into 10 to the power minus 7 Newton per meter. Right. So how to understand this? The force between them. So general formula, if you can consider here, is if you have two parallel current carrying conductors in which currents, two parallel wires are at a distance of 1 meter each. That means distance between them is d is equal to 1 meter. D is equal to 1 meter, and both of them carry 1 ampere current. Both of them carry 1 ampere current. 1 ampere current. So you can say this is I1, this is I2. Both are equal to 1 ampere. 1 ampere. This is also equal to 1 ampere. Both of them carry 1 ampere current. Then force of attraction per unit length between them, as it is given that force of attraction, you have to understand that current in both wires, current is flowing in same direction. It is not mentioned is the same direction, but it is mentioned that force of attraction between them. So when attraction will take place, you have to remember, when current is flowing in same direction, they will attract. In opposite direction, they repel. So you have to conclude, and you have to just realize that the current should be flowing in same direction. So the data you have to understand carefully. Yes, then the force per unit length. Force per unit length is equal to mu naught I1 I2 by 2 pi d. Simple. It is equal to mu naught. So we have to substitute. The options are not in terms of pi. Sometimes options will be given in terms of pi. Then you have to keep pi value as it is. So here mu naught is 4 pi into 10 to the power minus 7. I1 I2 are equal to 1. So 1 into 1, 1 only, by 2 pi into separation between them is 1 meter. So 2 pi 1s, 2 pi 2s. It is equal to 2 into 10 to the power minus 7. So that's it. This is simple question. How simple is it? So force per unit length, Newton per meter. Unit should be Newton per meter. That's it. These kind of questions are also asking even in JE. So don't think that very difficult level questions only will be asked in JE or NET. Simple question, simple substitution based question, guys. Right.